In this presentation, we will be discussing the use of mass spectrometry for food and wine provenancing. Mass spectrometry is a sensitive analytical technique that was originally developed to measure the atomic weights of elements and the natural abundance of isotopes. This technique can be used to quantify and identify the structure of molecules. In this technique, molecules or atoms are ionized, and the ions are separated based on their mass to charge ratio to produce a mass spectrum.
As shown in Figure 1, a mass spectrometer consists of a sample injection port, vaporization heater, ionization source, magnetic or electric field, and a detector. A sample containing atoms or molecules of interest is injected into the mass spectrometer through the injection port. The sample is then vaporized by a heater and ionized. Ionization methods that can be used include electron impact ionization, fast atom bombardment, electrospray ionization, atmospheric pressure chemical ionization, and matrix-assisted laser desorption ionization. The most common method is electron impact ionization. In this process, the sample is bombarded with electrons, which knocks electrons off of the atoms in the sample, resulting in the formation of positively charged ions. The ions formed are then accelerated through the instrument to electric plates and magnetic fields of mass analyzers, which deflect the ions. Commonly used mass analyzers include time of flight, orbitraps, quadruples, and ion traps. The amount that an ion is deflected depends on its mass and charge. Ions with a high mass will move slower than ions with a low mass, and therefore will be deflected less. Ions with a high charge will be deflected more. The ions that are successfully deflected by the mass analyzers hit the detector. The detector records the mass to charge ratio of each ion and the amount of ions that it detects. From this signal, the instrument generates a plot of relative abundance against the mass to charge ratio of each ion, which is known as a mass spectrum. This process is performed under a high vacuum to remove contaminating samples which can react or collide with sample ions, altering their path.
Food and wine provenancing is the process of finding where specific types of food and wine originated and exactly what they are produced from. Many people care about the quality, ingredients, health, animal welfare, and environmental impacts of the production of the food and wine they consume. By being able to locate exactly where products originate, these factors can be determined, giving consumers confidence about supporting companies that follow ethical animal treatment and consumer safety practices. The capability to certify food origin or authenticity is of significant economic importance to many stakeholders, especially in cases where the marketability and export value of products can be increased by adding label elements based on standards of identity or composition related to a very specific production area or production practices. Provenancing methods allow the identification of counterfeit and adulterated products, which can help deter and find and stop criminals producing counterfeit food and wines. This is important for the economy and reputation of countries selling authentic produce. Provenancing is also important for cultural and religious purposes in situations where ingredients or the origin of a food product may make it unfit for some consumers. In cases where the production location of contaminated food or wine products needs to be determined, in order to identify other potentially hazardous products and prevent them from being sold, food provenancing methods are important. If the production region can be determined scientifically, product recalls can be minimized, reducing the economic impact, food losses, and damage to the industry and consumer confidence.
There is no single type of mass spectrometry that can be used across all food and wine provenancing applications. Usually, mass spectrometry is coupled with gas or liquid chromatography. NMR or advanced mass spectrometry techniques can be used. Two commonly used advanced mass spectrometry methods include isotope ratio mass spectrometry and inductively coupled plasma mass spectrometry. IIMS is a technique where the isotope ratios are analyzed using mass spectroscopic techniques. Stable isotope ratios change with the climatic conditions, geographical origin, soil type, and geology of the locations of the food's origin, hence why isotopic ratios are applicable to food authentication. As a primary indication, hydrogen and oxygen isotopic data for organic matter in food are linked to the hydrogen and oxygen isotope data of water from the source region, which have geographical variability. Nitrogen and carbon isotopes are related to the climatic changes and the agricultural practices, and sulfur isotopes are affected by geology, distance from the sea, and certain anthropogenic effects. ICP-MS combines a high-temperature inductively coupled plasma source with a mass spectrometer. The ICP source ionizes the atoms of the elements in the sample, then the produced ions are separated and detected by the mass spectrometer. Inductively coupled mass spectrometry is used almost exclusively due to its ability for multi-element measurements. It is a valuable approach for elemental analysis, detecting traces of toxic metals such as lead and arsenic in foods and beverages.
Wine, the popular alcoholic beverage produced from fermented grapes, is one of many food products that has a high commercial value. Due to this, the production of counterfeit wines is a common issue that has a huge negative impact on the economy. The number and concentration of chemical compounds found in wine are influenced by grape variety, location of grapevines, weather conditions throughout the grape growing period, and wine production processes. This allows wine grown in different regions to be differentiated by analysing the chemical composition. In previous studies, inductively coupled plasma mass spectrometry has been used to successfully determine patterns in the minerals and trace elements in wines. Therefore, by using ICP-MS to analyse wine known to be authentic and comparing the mass spectrum produced to the mass spectrum of a suspected counterfeit, it can be determined whether the wine is authentic.
Rice is a global staple food that is consumed by more than half of the world's population. Consumer confidence in rice quality and the reliability of labeling information is undermined by rice mislabeling and adulteration. Because of the way rice is grown, it can harbor arsenic, which is a major threat to human health. By using isotope ratio mass spectrometry, previous studies have been able to determine the geographical origin of rice samples and also determine the source of rice contamination.